In this video, we're going to look at the two main types of digital images that you would be working with. So in graphics and in graphic production, we have two main categories of images. One is vector graphics, and the other is raster images or bitmap images. The difference is that vector graphics are mathematically created. They are mathematical formulas that make your lines and your points and your fills and your shapes and so on that you fill with a color. So like using Illustrator and other simple drawing programs, those are vector graphics when you have points that you can edit and shapes and fills. Compared to bitmap or raster images are essentially just a grid of pixels, and those pixels can be modified and altered, but it's just a set grid with pixels arranged in them. And we'll take a look at those a little closer right here. Vector graphics are mainly used for illustrations and graphic elements and logos. And the main benefit of using a vector graphic is that they're small file sizes, and you can enlarge them or reduce them to whatever physical dimension size you want without losing any resolution or quality. So you can expand them up to a billboard size or as small down as a business card, the same graphics file, and you would come out with the same quality with each size. And that's because it's mathematically calculated lines. Some of the negatives to it, the cons, is that it's not really great for photographic images, and it's hard to edit and color correct photographically and apply photographic filters and styles to them. So that's kind of the main difference. Just to show you really quickly, there's on the Wikipedia site for Bezier tools. Let me just arrange this so you can see it better here. This is what vector graphics is about, and this is when you use the pen tool in Illustrator or Photoshop or InDesign. And this is kind of how it works. It's kind of cool Wikipedia site because it has these animations down here, but you can see it's all mathematically based. Now, if you are into math, you might enjoy this, but to me, it looks like a foreign language to get these formulas of geometry and how they work together. So let me get down. There we go. That's looking really great. So there's a basic line geometrically. Here's your curves. And then a little more complex curves. Just giving it a second here to show it drawing, and even more complex curves. So you can see that it's just a mathematically based set of drawing lines and then filling them with colors. You can get photographic quality with vectors, although it takes a lot of work or a lot of computing power. So here with this this image, you can see this apple or whatever that is, a tomato dropping into water is a vector image, and each one of those shapes has its own fill and gradient and so on. So file formats used for vectors are basically Illustrator files, EPS files, which are PostScript, encapsulated PostScript, that's what that means, PDF files. Other ones that are web-based, you got your Windows meta file or media file, meta file, your SVG, scalable vector graphic, and your SWF, your shockwave flash, which Flash is going bye-bye, so I should take that off of there. Don't use Flash. Okay, so raster images, also called bitmap, is basically pixels arranged on a grid. So the main benefits of this is that you get photographs, photographic quality, and you get image editing capabilities, color correction, that sort of stuff. The cons to it is that you get really large file sizes with bigger photos, and if you try to enlarge them, you can have resolution, loss of quality through resolution. So most most file formats used for this are PSD. We've talked about this a little bit too. TIFF files, EPS, JPEG. Those are good for print. Your web-based is JPEG, GIF, PICT, PNG. These two here, the RAW and DNG, those are camera files. So RAW is a camera file for when you take with a digital high quality camera, you get raw image data. Or DNG is digital negative. So for a camera is like a digital negative. It's high quality data from the camera, and then you save it into Photoshop and you can manipulate it from there. But basically, let's see, I got a Photoshop file here of a raster image. This is a church down on Broadway Street in Bellingham. And just to show that it's a pixel, if I just zoom in here, and you'll see Photoshop is saying, oh yeah, see, that's a grid of pixels that each one has a color and a value and a hue, and that's all that it is a grid of pixels. So there's different modes for raster images. You can have your bitmap. It's a different use of the term. Bitmap art, which is either black or white pixels. A grayscale, which has 256 shades of gray. And then you've got like duotones and your 4-color images, your full color images. So just to go back to this file here, if I go to the edit mode and say grayscale, it asks me, do I want to discard color information? I'll say yes, I discard that. And then when I look at my layers here and the channels, I can see I've got one channel and it's gray. And if I zoom in on this, you'll see that all the pixels are a shade of gray, right? So there's 256 shades of gray, and that's how that works. If I go back to my image mode and go to bitmap, sorry, that was off screen. And if I switch it to bitmap and say 50% threshold, that tells Photoshop anything that is less than 50% gray gets turned to white, and anything over 50% gray gets turned to black. Or if I use a pattern dither or diffusion dither, what that does is it does the same thing. It'll either change them to white or black, but it'll create these little dots and try to keep the shading the same. So if I do that and say okay, it looks kind of the same, doesn't it? But let's zoom in on it now. Whoa. Yeah. So you can see all those pixels are now either white or black. There are no gray pixels there. And it's just a matter of spacing them out to get your shades of gray. So that is similar to the FM screening, stochastic screening that we talked about last week. This does not reproduce well, and this image mode of bitmap is really best for like sharp black and white logos and graphics, and not necessarily good for photographic images. And so when working with bitmap, resolution matters. It's really important to be taking close attention to it. For line art, for bitmap, you can go 600 ppi. But for regular, your color photos or grayscale, duotone, whatever, 300 ppi is the minimum. And this is just an example showing how, if you try to enlarge, how it can get pixelated. And this graphic off to the side here just demonstrates why that is, and that the more pixels you have, the finer curves and sharper edges you'll get. With the fewer pixels per inch, you'll get rougher edges.